So here they want you to take this equation and to repackage it and to rewrite it into Cartesian form. Cartesian is the same as rectangular. Rectangular is x's and y's. So let me first take a few reminders and throw them at you. So these should look familiar, yes? Now, what I want to do is I want to take the last equation and I want to square root both sides. Is that okay with you? If I square root this side, I get this. If I square root this, I get that. So these here, these are just a couple of resources that I have at my disposal. So now let's actually begin this problem over here. So what I want to do is I want to multiply both sides by 1 plus 2 cosine theta. So here's what I get. Are you okay with what I did? I basically cleared out the denominator. So here's what I have up to this point. Now why don't I go through and distribute this? Okay, so look at what you have here. Now notice that what could replace r? Well, this could replace r, because that's what r equals. What could replace that there? R cosine theta can be replaced by x. So let's go through and make some of these changes. Okay, you okay with what we have here? Okay. Now let me take the 2x and move it to the other side. Now what I'd like to do is I'd like to protect both sides and then square both sides. So check out what just happened. I squared the left and it's just x squared plus y squared because this knocks this out. I squared the right, but I showed my work in blue. I used the distributive property and that's what I got there. So let's continue from here. Okay, so a couple of things just happened. So I subtracted x squared from here, that was gone. And that 4 minus the 1 gave me that 3. And then I subtracted y squared, those are gone. And I wrote it somewhere. I had to write it somewhere, so I just decided to write it right there. So there's nothing here, that's a 0. Okay? So those ones gave me a 3. And then that negative 24x is there. The negative y squared followed. And the 36, which is positive, I just put it there. So let's continue from here. Okay, so I took out a 3 from these two terms. That's how I have what I have here. I put a little plus a blank because we're going to complete the square. Okay, and then that stayed there. And I took the 36 and I subtracted it to the other side, which is why it's negative. And I have to add the same thing here. Now, what goes in this blank? So if you're with me, this should be 16 here, and this would actually be 48 there. Now, first of all, how did I get 16? You have to take half of this number, square it, and that's what goes in here, okay? So half of 8 is 4, 4 squared is 16. How come I put a 48? Because this 16 is actually really a positive 48, and you balance it onto this side. So now, let me go up here. So now what I can do is that's just 3. Now this here, that is always going to be something squared. That's why they call it completing the square, because you turn it into something that gets squared. Always keep the first operator, we're using x's, and always take half of this. And that's what goes in there, okay? So now I have minus y squared equals 12. Now recall that here, you have to have this number there. That has to be 1. So let's divide every term by 12. So divide everything by 12. So let me make a couple of comments before I let you go. So this is the final answer. Now technically we were actually finished. Technically this is the answer here. Because what was the goal? The goal was to write it into Cartesian or into rectangular form. which means only x's and only y's. And we actually accomplished that here like 5 minutes ago. But math teachers are very picky. They want answers written in a very specific way. And that's why we had to take this and do all of this math to make it look like something that is more recognizable, okay? So final answer is here. One more thing before you go. This was what number was this? This was number 38, I think, is that right? That was number 38. As it turns out, number 37, number 37 is ugly. It's much uglier than this one, but it behaves in the same way. And there's a lot of fractions. That's what makes it really unpleasant, okay? Unless you like that sort of thing. So why don't you try number 37 out of the book? It's gonna behave like this, but prepare for a lot of fractions when you get to this step. So try it and then check the answer, which is in the back of the book. I'd like to check my answer really fast here on Desmos. So in box number 1, I have the original problem, which is in polar form. That's what it looks like. In box 2, I have our answer, which is in Cartesian form, or sometimes they call it rectangular form. It's the same thing, Cartesian and rectangular, same thing. I'll activate it in blue, boom. See how it perfectly traces the original one? So watch, let me take it off and put it back on, and so on and so forth. So that's how you know, that's how you can check your answer. So they should make the same graph, and they do. So for sure, what we got here in box number 2 is correct.